we'll just try someday. We have never tried. So it might become a total disaster. No. Make it. Make it. Okay guys, so we will discuss, so I will be discussing some questions that you find difficult, or we can just, I have just selected a few questions from the June 2017 paper. Okay, so any questions that you want to discuss, you can, let me know. Shall we do question number 3? Okay. Okay, so we'll discuss this question. I have already received one question from, can you send me the year of this paper, Pata? The year, this is 2019 June, right? Okay, so I will take that paper next. For now, shall we start off with this question? Let's discuss this one first. Okay, give me a moment. Okay, shall we try this one first? Okay, so we will discuss, shall we discuss this one? This is June 2017, okay, this is June 2017 IAL, okay? Okay, I will discuss this one. Okay, given that y equals x minus r tanh 2x over 1 plus x square. Okay, so given that y equal x minus r tanh 2x over 1 plus x square, show that. Okay, you have to show that 1 minus dy by dx equals k over 1 minus x square. Okay, obviously what do we have to do first? First we have to get dy by dx. Okay, how do we get dy by dx? We need to differentiate. Okay, let's go for the differentiation. By the way, you need to know the differentiation of r tanh. R tanh. Can I know the differentiation of r tanh? Quickly remind me. Differentiation of r tanh x is? Can I have the differentiation of r tanh x? It's there in your formula books as well. I think I have also, yeah? R tanh x differentiation is 1 over 1 minus x square. So, however, if it's r tanh fx, it will be 1 over 1 minus fx square, is that all? Into f dash x. This is the important thing. Okay, so when it comes to this kind of a rule, r tanh fx 1 over 1 minus fx square into f dash x. Okay, so then we'll apply that rule now, dy by dx. So dy by dx equals differentiation of x is 1. Differentiation of x is 1. So r tanh fx. So fx is 2x over 1 plus x square. Okay, so fx is 2x over 1 plus x square. So how do we go for the differentiation? Minus 1 over 1 minus 2x over 1 plus x square whole thing square. Okay, so that is the square of that into the differentiation of 2x over 1 plus x square. Okay, so this is the denominator, and then you have to multiply with the differentiation of 2x over 1 plus x square. Okay, so how does the differentiation work? So how does the differentiation work? 2x over 1 plus x square, you can go with quotient rule. Now you can see we have to differentiate this, we can go with quotient rule. So how does the quotient rule work? The denominator you will square it, right? Denominator you will square it, and then denominator times, differentiation of the numerator. 2x differentiation is 2 minus, you keep 2x here, 2x times differentiation of the numerator is, numerator times differentiation of the denominator. So 1 plus x square differentiation is another 2x. Guys, are you okay with what's going on here? Okay, then let's simplify. And so now we need to simplify this and get this show that. So you can see the type of show that we have over here. We need to simplify all these terms and get the show that. Okay? Okay, so let's go for the show that. dy by dx equals 1 minus, how do you simplify this? 1 over 1 minus, this is going to be 4x square, right? Because I'm going to put the square in, 4x square over 1 plus x square whole thing square. 1 plus x square whole thing square, are you with me? And this is also going to be multiplied by 2 plus 2x square minus 2x into 2x is 4x square over 1 plus x square square. Do you agree with me? Okay, then let's open up the bracket and simplify. 1 minus 1 over, I will be taking the common denominator with what? 1 plus x square. I will be taking the common denominator with 1 plus x square, 1 plus x square square. Okay, and minus 4x square whole thing divided by 1 plus x square square. Guys, are you okay with this? So times, over in the numerator here I can simplify 2x square minus 4x square will give you minus 2x square over 1 plus x square the whole thing square. Okay, just be really cautious here because you need to realize this one is separately situated. Like these two guys are a product here, but this one is separately there. Okay? Right, then what do? We need to simplify this. Yeah, we can bring the denominator, the 1 plus x square, which is in the denominator here, we can bring it up to the numerator, isn't it? So we can bring it up to the numerator. How does it work? 1 minus, yeah, the 1 plus x square square will come to the numerator. 1 plus x square square comes to the numerator. In the denominator, I am going to have 1 plus x square square minus 4x square. Actually, we can expand this bracket, shall we? How do I expand it? 1 plus x square square, when you expand, it's going to give you 1 plus, yeah, tell me? 1 plus x square square. So it's going to be twice of these two, right? 1 plus 2x square, because you have to take the double of these two guys, plus x to the power 4. That's when you expand this bracket. And then separately there's another minus 4x square. Are you guys following me? And over there on the other side, what do I have? 2 minus 2x square. I can actually take a 2 out, isn't it? Taking 2 out gives me 1 minus x square over 1 plus x square square. What is the next ideal step? What do we cut? The numerator and denominator 1 plus x square square, 1 plus x square square can be completely cut out. Do you agree? Okay. And then we need to find a way of simplifying the denominator now. Okay, over in the denominator here I have 1, what are the like terms? Can you see I have plus 2x square minus 4x square, that gives me minus 2x square plus x to the power 4. Do you agree? Times, over here I have 2 times 1 minus x square. Okay, now what? Okay, so now what? Yeah, so how do we get this show that? Yes. The show that is d1 minus dy by dx equals k over 1 minus x square. Without opening the bracket, how do you suggest to do you? With what? This is a 1 plus x square, yes? Yeah? Yeah, it's a minus over here, so these can't cancel. So what can I do here? The show that is, once again, 1 minus dy by dx equals k over 1 minus x square. So how do I get this show that? What is the next ideal thing I should do here?
Ma'am,
Yes?
and would factorize the denominator, ma'am.
We can factorize the denominator. How do you factorize this denominator? 1 minus 2x square plus x to the power 4. It's actually quadratic here. It's a hidden quadratic here. How does it work? Yeah, how does this factorize? 1 minus 2x square plus x to the power 4 can be factorized as 1 minus
1 minus x square.
1 minus x square, yeah, square. 1 minus x square square. Okay? Times 2 into 1 minus x square. Guys, can you see how this works? And then we can cancel out a 1 minus x square, one of them. Because it perfectly cancels out. And then you have 1 minus, the 2 comes on top, 2 over 1 minus x square. So dy by dx. I think the show that was 1 minus dy by dx equals k over 1 minus x square, right? Yeah, so I think all I have to do here is to take the dy by dx to the other side and bring the minus 2 over 1 minus x square over to the other side. So 2 over 1 minus x square equals 1 minus dy by dx. Guys, are you clear with this? Yes, is this okay? I think there was a request to do, what was the paper once again? June 2019. Yeah, y'all can, send any questions that you want me to discuss on the chat. The request was from June 2019, question number 8. Okay, so we'll do that. June 2019, question number 8. Let's do that. Actually, I think June 2019. Dulashika, right? Can you send me that paper? Wait. Okay, while I get that paper, we'll go for another one because I had to get that paper. We'll go for another question meanwhile. Yeah, shall we try the reduction formula question? I think this is one of the most, one of the toughest questions, right, in the paper. This is again, what was the paper that we were discussing? June 2017. Yeah. This is again June 2017, question number 5. Okay. Right, so shall we discuss now this one? Okay, question number 5. Okay, how do you go ahead with this reduction formula? Normally when it comes to reduction formula question, it comes to the art of kind of like, how you break this up and how you apply, parts by integration, isn't it? Okay, so how do we work with this one? What is the ideal way, the best way to, break this sum? In equals, you have cosec x to the power n. Okay, I want you all to think about the way that we can break this sum. Okay, how do we do this? Okay, so how do I do this? How do we break this up? The thing is, I want you all to suggest me ways how I could, break this. cosec to the power nx. So how do we break this up? Normally sometimes we break it as cosec n minus 1 into cosec x.
Ma'am,
Yeah?
since we see n minus 2, could we take cos x power 2 x?
Yes, that is the ideal. Now the thing is, you need a little bit of practice to identify exactly what's going on here, because I immediately to think of the way you break this is actually you have to think like how do we go for the integration, how do we do the parts by integration. Okay, so the best way that you do actually do this question is you break this up as cosec to the power n minus 2x into cosec square x. Why do I go like this? Okay, so the thing is, do we know how to integrate cosec square x? Go through the rules. Let me take my rules. Okay, so these are my integration rules. So you can see that we know how to integrate cosec square. Can you see? Yes, so we know how to integrate cosec square. So this is one of the reasons that we break this up as cosec n minus 2 into cosec square, because we know how to integrate cosec square. Can you see? These are the rules I have written in P4. Okay, by considering P4. Okay. Okay, so then let's break it up as cosec to the power n minus 2x into cosec square. Shall we? Okay, so then why am I doing that? What is the reason that I break it up in this manner? I'm going to use parts by integration, and the reason that I break this up in this manner is because I know how to integrate cosec square. Okay, so the basic integration rule that I'll be following is integration of u v dash is what? uv minus integration v u dash. This is the parts by integration rule we learned in P4. Do you agree with me? Okay, so then let's go ahead with this. So I want you all to tell me how the integration works. So I will first identify my u and my v dash. Okay, who is u and who is v dash? The obvious reason I broke this up as cosec square is to integrate it. So this is going to be v dash. This is obviously going to be v dash. And this will be my u. This will be my u. Okay, then shall we fix this over here before we go to directly apply? I prefer to have everything written properly before I do this. Okay, let's write this u equals cosec to the power n minus 2x. Okay, so how does the differentiation work? U dash, the first priority. Whenever you are differentiation, first priority goes to the power. So then the power comes forward first. So n minus 2 and then cosec x to the power n minus 2 minus 1, n minus 3. So this is how differentiation works. First you give priority for the power. After you're done with the power, go inside and now you differentiate cosec x. What's the differentiation of cosec? Cosec differentiation, okay, so you need to remember the cosec differentiation rules also, right? I have taken the integration rules here. What's the differentiation of cosec? Minus cosec x cot x. Okay, so into differentiation of x is 1. Okay, then shall we just simplify this a little bit more? How do I simplify this a little bit more? I want to get u dash in the simplest form. N minus 2 cosec x to the power n minus 3, and here there's a cosec x to the power 1. So I can make this a cosec x to the power n minus 2. Can you see? So this is going to be cosec to the power n minus 2x into cot x, and don't forget, I think there is a minus mark also, right? Here this minus mark, just be cautious. Okay? Okay? So that is u dash, and now let's go for v dash. So v dash to v. V dash is cosec square x. Can I know v dash to v, what do? We integrate. So can I know what is the v? Cosec square integration is? So you can see I have it over here. Cosec square integration is minus cot x, because I don't have a value over here. It's simply cosec square x. It's going to be minus cot x. It's going to be minus cot x. Are you with me? Mummy pass. Okay, and then let's continue. Let's apply these rules now. Okay, let's apply these rules. Okay, shall we apply the parts by integration rule now quickly? So uv minus integration v u dash. Okay, how does it work? So uv, I have written the u and v, everything is written over here clearly. All I have to do is to apply these into the equation. Okay, shall we? Okay, so uv, how does it work? U is cosec to the power n minus 2x into v is minus cot x. Can you see? Okay, and then minus integration sign, b is minus cot x into u dash. U dash is minus n minus 2 cosec to the power n minus 2x cot x with respect to x. Guys, can you understand what I just did here? I applied this rule. I substitute the u, v, u dash, everything into this equation. That's what I did. Okay? Okay, and now we have to simplify and try to get the show that. Okay, so let's try to get the show that. Okay, so let's try to get the show that. Okay. So in equals cosec to the power n minus 2x. There's a minus mark in front, right? So don't forget it. Minus cosec to the power n minus 2x cot x. And then over here, how do I simplify? What can I take out? You can take the constants out. Okay, what else? N minus 2 I can take out. Yeah, and then you can see we have a pair of minus signs inside, right? So these two minus becomes a plus. So will not affect the minus mark outside. So it will be a minus still outside the bracket, and I'll take the n minus 2 out because it's a constant and it will not impact our integration in any way, right? Okay, I get here cot square x into cosec n minus 2x dx. Okay, so I come to this point. Okay, now what? Now the thing is, I want to try to get this show that. Okay, I want to get the show that I need to create a in minus 2, right? So in minus 2 is integration cosec to the power n minus 2x. I need to create an integration cosec n minus 2x alone. Like I can see I already have an integration cosec n minus 2x, a power n minus 2x, but it's with a cot square. It's with a cot square, so then it will, I can't directly say this as in minus 2, can I? No, I can't say this as in minus 2. Okay, so then what do I do? Okay, so how do I, try to go for the show that now? Do we go for integration by parts again? How do we go for the show that? I want to get this show that in minus 2. How do we do this? Yes, what identity are we going to use? Yeah, so we can go for the identity that involves cot square and cosec square. So how does that identity work? 1 plus cot square x equals cosec square x. So I can rewrite this cot square x as cosec square x minus 1. So we are not going to go for performing any integration again. We are trying to create the in minus 2 here itself. Okay, we'll try to create that here itself. Okay, how does it work then? In equals minus cosec to the power n minus 2x cot x. Over here you have n minus 2. And what do I do here? Inside the integration sign, I have, instead of cot square, we will go for cosec square x minus 1. We will go for cosec square x minus 1. Are you with me? And then outside you have a cosec to the power n minus 2x dx. Agreed? Is this okay? Okay, now what? What's the next step? What is the next step? Minus cosec n minus 2x
multiply
cot x. Yeah, we have to multiply this, right? Yes, so how does the multiplication work? Let me use a large bracket over here. Be careful. Yeah, cosec n minus 2x into cosec square is going to give you cosec to the power nx. Cosec square, the powers add up and minus 2 plus 2 cancel. So you get here integration. Okay, don't forget the integration sign. So it will be integration cosec square, sorry, not cosec square, it's going to be cosec to the power nx. Okay, minus cosec to the power n minus 2 into 1 is cosec n minus 2x. Both of them are with respect to x, right? Can you all understand what I just did over here? Okay, yeah. And now you can see integration of cosec to the power nx is actually what? Cosec to the power nx is directly in. Integration of cosec to the power n minus 2 means it is directly in minus 2. So actually you can see now I don't have any other terms that disturb, right? I directly have the in and in minus 2 with the integral sign, okay? So then let's apply those values. In equals minus cosec to the power n minus 2x cot x minus n minus 2 times over inside the bracket I have. This is going to be in, this is going to be in minus 2. So actually we had to make in the subject, right? So shall I make the in terms to one side? So over here I have in and over here I have minus n minus 2 into in, right? So shall I take it to the other side over here because I want to take all the in terms to one side at once. So what do I get here? In, can you tell me how it works? Plus n minus 2 in. Because I just took this term to the other side, like this term. These two guys together, I took it over here. Do you agree with me? Okay, and then this is equal to minus cosec to the power n minus 2x cot x. Yeah, over here now just be cautious because you are going to open the bracket with n minus 2. Minus n minus 2 into minus in minus 2 will be minus into minus because you are going to expand this bracket with this person, right? This term I have taken it to the other side already. So this one I will take minus n minus 2 into minus in minus 2 will be plus n minus 2 times in minus 2. Okay? Yeah. So now let's simplify this over here. If I take in out, I get here 1 plus n minus 2. So I'm just writing extra steps. I think you can reduce a few of these steps because I'm writing all the steps here. But you could reduce some of these extra steps that I've written. Okay? And this is basically going to be what? N minus 2 plus 1 will be n minus 1. So shall I directly write it? Saves our time, right? And then finally to get the show that in equals, look at the show that in equals, yeah, minus 1 over n minus 1 cot x, yeah. So we have it over here, right? Minus, so minus cosec to the power n minus 2x cot x over, or you can say minus 1 over n minus 1 over here plus, you take the n minus 1 to the denominator of both of these parts. So it comes over here and it also comes to the denominator of the other side. In minus 2. Yeah. I think this is our show that. Is that the show that? Yes, right? We got the show that. N minus 2, n minus 1, in minus 2. Yes, right? Minus 1 over n minus 1, cot x cosec to the power n minus 2. Yeah, so I have it. Okay, is this clear? It's just the way that you integrate here, the way that you break up, and also writing these parts over here at the very beginning is going to be helpful. Okay? Then we'll move to part B. Okay, part B, what are we supposed to do? Okay, how does part B work? They are asking you hence or otherwise find the integration of cosec x to the power 4. With respect to x. Obviously, who is this? So we have in defined here as integration of cosec x to the power n, right? So this is going to be cosec x to the power 4 means this is I4. So obviously it's I4. So what do we do here? You go back to the equations. You come back to the in equation. Replace all the n values with 4. Replace all the n values with 4. So let's replace all the n values with 4. 4 minus 2 over 4 minus 1 times I4 minus 2, that's going to be I2. 1 over 4 minus 1, that's going to be 3. Cot x cosec to the power n minus 2x. Sorry, not n minus 2. We are going to replace n with 4. So that will be 4 minus 2 will be cos x square x. Guys, do you agree with me? Cot x, cos x to the power 4 minus 2, yeah, cos x square x. So when you simplify, I get here I4 equals 4 minus 2 is 2, 4 minus 1 is 3, I2. Let me rearrange this. I'll bring this guy, I'll write this person first. Minus 1 over 3 cot x, cos x square x over here, plus I'll write the next term over here. This guy I'll write it over here. 4 minus 2 is 2 over 4 minus 1 is 3, I2. Okay, now what do we do? So we are going to use the equation for I2 back into this equation. Go for I2, replace all the n values with 2. Okay, replace all the n values with 2. So how does it work? How do we... you're saying me to not to go for I2 for the reduction formula, but rather we can go for I2 with this equation itself, because we know how to integrate cos x square. Okay, that's a good idea. That's actually a really good idea, because using this equation is going to be very long, right? Yeah, so actually it's easy. Yeah, so if you use this equation again, you will end up getting I naught. So I naught is okay. So we'll go with I2 directly from the equation, because we know how to integrate cos x square, right? Do you get what the suggestion was? The suggestion was for I2, instead of going for the reduction formula, let's go with this. So I2 will be integration of cos x square x with respect to x, right? So then how do we do the integration of cos x square? So I have the rules. These are P4 rules. Cos x square x integration is minus cot x, isn't it? Cos x square x is minus cot x. So let's take it. This is directly minus cot x. So this is I2. Shall we substitute the values, and they tell you to give the answer entirely in terms of cot x. So I can't have any cos x square terms here. Everything should be entirely in terms of cot x. Okay, let's get the answer. So I2 coming back here, I4 equals minus 1 over 3 cot x, cos x square x, plus 2 over 3, I2 will be minus cot x. Guys, do you agree with me? Now what? How do I get rid of this cos x square? The question says to get the answer entirely in terms of cot x. So I think you can see this is a cot x. All of these guys are good except the cos x square here. So what do we do for cos x square? 1 plus cot square is cos x square. The basic trigonometry formula you learn in P2, isn't it? Okay, so then let's apply that. I4 equals minus 1 over 3 cot x. Cos x square will be 1 plus cot square x. Do you agree? Cos x square x is 1 plus cot square x. Over here, 2 over 3 into minus cot x is minus 2 over 3 cot x. So I4 equals, I think we'll have to expand the bracket here, shall we? Minus 1 over 3 cot x into 1 is minus 1 over 3 cot x. Minus 1 over 3 cot x into cot square x is minus 1 over 3 cot cube x. And finally, after you open the bracket, there is a minus 2 over 3 cot x, right? Minus 2 over 3 cot x. Okay, so are there like terms that I can simplify here? Yeah, so I can get these guys together. Minus 1 over 3 cot x, minus 2 over 3 cot x are like terms. So when I add them together, how much is minus 1 over 3 plus minus 2 over 3? That will be minus 3 over 3, minus 1. So minus 1 or minus cot x, minus 1 over 3 cot cube x. And then don't forget a plus c at the end, because there is no limits here, so you have to give the integration constant. Okay? Okay, this question is clear, right? Okay, so we'll go for the next one. Okay, if there are any doubts, you can ask me. We can, you can discuss. We'll do the sixth question also, right? Shall we? Yeah, same paper. I'm just going through the sums and trying to see what is the most difficult. So these are questions from the June 2017 paper. Okay. Okay, let's try this one. Question number 6. Okay, they say the hyperbola h has equation x square over a square minus y square over b square equal 1. And the ellipse E has equation x square over a square plus y square over b square equal 1. Okay, you have a hyperbola and you have a ellipse. You have a hyperbola and ellipse. Okay, where a is greater than b greater than 0. The line L is a tangent to hyperbola h at point P, a sec theta, b tan theta, where theta greater than 0 and less than pi over 2. Using calculus, show that an equation for L is bx sec theta minus ay tan theta equal ab. Okay, so this is something that you should be like you can get this quite easily, I believe. Okay, maybe the part B might be the more challenging part, but part A you must surely be able to score these 4 marks, right? Okay, how do we do this? Okay, so let's differentiate. Basically, to get the equation of the tangent to hyperbola, they have highlighted here also that you need to get the tangent to the hyperbola, meaning the first equation. Okay, the tangent to the hyperbola. Okay, so what do we do? First thing is we have to differentiate, get dy by dx. Dy by dx gives the gradient of the tangent, and then we have to get that gradient of the tangent and get the equation of the line. Okay. So let's get the equation of the hyperbola h. So hyperbola h has equation x square over a square minus y square over b square equals 1. Okay, so now I want you to differentiate. So we will go with the P4 techniques of differentiation, implicit differentiation. Okay, I will not try to make y the subject and differentiate, but rather we will directly go for the differentiation. When there is a power, the power gets the first priority, and then you differentiate inside the function. So a square, b square in the denominators are simply constants, right? So like you could rewrite it like this. Could be written as 1 over a square times x square minus 1 over b square times y square equals 1. Do you agree with me? Okay, and then let's go for the differentiation. So I will differentiate with respect to x. Okay, so I will differentiate with respect to x. You don't need to write these stuff actually, you can directly go for the differentiation. So I get here 1 over a square is a constant which will wait. X square differentiation is 2x minus 1 over b square times y square differentiation is 2y. Okay, is that all, by the way? Y square differentiation is just 2y to the power 1? No, right? I am differentiating with respect to x. Thereby, when you differentiate with the y square with respect to x, okay, the power comes forward. You subtract 1 from the power, but into the differentiation of y, it's dy by dx. So you have to be really cautious with that. Okay, equals to differentiation of 1 is 0. Differentiation of 1 is 0. Okay, and now what do we do? Make dy by dx the subject. Okay, let's make dy by dx a subject. So I get here 2x over a square. The minus goes to the side as a plus. 2y over b square times dy by dx. Do you agree with me? I just took this entire term to the other side as the negative term to the other side as a positive. I just took the entire negative term to the other side as a positive. Okay? Okay, so now what do? We'll make dy by dx the subject. We'll make dy by dx a subject. So when you make dy by dx a subject, what do we do here? I get here, actually I could cancel out a 2 over here. Shall I cancel out the 2? And I get here b square over a square and x over y. I just wrote it like this. You could write under a common line, that's fine. So xb square over ya square, something like that. So I got the dy by dx, this is the gradient of the tangent, and then what do? We don't keep the gradient in terms of xy, right? We need to immediately substitute the coordinates, the place where we are finding the tangent. We are finding the tangent at the point a sec theta, b tan theta, isn't it? Shall we substitute the x and y values? So the gradient will be b square over a square times x over y. X is going to be a sec theta because I'm trying to find the tangent at that point, a sec theta, divided by y is b tan theta. And we can simplify this slightly, right? So you can cancel out a b here, a single b term, you can cancel out a single a term, and you end up getting b sec theta over a tan theta. And by the way, are we trying to, right now, sec is 1 over cos, tan is sine over cos. Is it necessary to replace sec with 1 over cos and tan with sine over cos? No. Why? Because you keep your eye on the show that. Now your show that is having terms entirely with sec and tan. So we will not try to replace the sec with 1 over cos and tan with sine over cos. We will keep it as it is because we need the answer show that in terms of sec and tan. Okay? So now let's go for the equation of the tangent. Should be easy, right? The equation of tangent is gonna be, so always I will use the technique we go in P1, the equation of tangent, y minus y1 equals gradient, x minus x1, right? So what's the y1 x1? y1 x1 is the line, the point that your tangent passes through. The tangent passes through point P, a sec theta, b tan theta. So then x is going to be a sec theta, b is going to be, y1 is going to be b tan theta, gradient is b sec theta over a tan theta. So if you have any questions, you can ask, okay? Into x minus, who is x1? x1 was a sec theta. Okay, x1 is a sec theta. Okay. And then let me take the a tan theta to the other side. So y into a tan theta is a y tan theta minus b tan theta. Now I'm actually taking the a tan theta to the other side as a multiplication. Okay. So the a tan theta will multiply with y and the a tan theta will multiply with b tan theta. Yeah. So a tan theta into b tan theta is minus ab tan square theta. Equals on the other side, you need to expand the bracket with b sec theta. So b sec theta into x and, yeah, it's going to be b sec theta into x is b x sec theta. Should I write like that? Just rearranging the order. Minus b sec theta into a sec theta is ab sec square theta. Okay, now let's try to look at the show that. What do we have in the show that? Bx sec theta minus ay tan theta, right? So I need to have bx sec theta minus ay, which means what? I should take the ay tan theta to the other side. And the, ab sec square theta, we'll take it to this side. Okay, then we can try to get the identity. Minus ab sec square theta, I'll take it over here as plus ab sec square theta minus, over here you have ab tan square theta. Over here we get bx sec theta, and what comes to the other side? Ay tan theta comes as minus ay tan theta. Minus ay tan theta. Okay, and now what? Yeah, we can take the ab out first, right? Take ab out, and what do you get here? Sec square minus tan square. Yeah, so who is sec square minus tan square? So these are again the identities you need to remember. What was the identity we used? 1 plus tan square is equal to sec square. So if 1 plus tan square is sec square, clearly you can see sec square minus tan square is directly going to be 1. Sec square minus tan square is directly going to be 1. Okay. So this is going to be ab times 1, which is ab, and this guy is entirely 1. So ab equals bx sec theta minus ay tan theta, which is the show that, right? Bx sec theta minus ay tan theta equals ab. So this is a 4 mark that you can easily score. Okay, so you should just do it really fast and get these marks. It's quite easy to get it. Okay, shall we go for the next one? Okay. Okay, then let's go for part B. Thank you. I'll take you out on me. Okay, part B. Given that the point F is the focus of ellipse E for which x greater than 0, okay, and that the line L, okay, you guys need to now focus on what's going on here. What's happening? The thing is, you have the hyperbola and you have an ellipse. They say there's a hyperbola and ellipse. Now, currently, we found the tangent to the hyperbola, isn't it? We found the tangent to the hyperbola at that particular point. Now, they say, given that the point F is the focus of ellipse E for which x greater than 0, and that the line L passes through F. Can you see what's happening? Line L is what we found here in part A. This line is passing through what? Is passing through F. Who is F? F is the focus of the ellipse. Okay, I want you all to remind me once again, what is the focus of an ellipse? So, focus of an ellipse, you can find this in your formula book as well. Okay. So, I think over here. So, formula book in an ellipse. In an ellipse of the form x square over a square plus y square over b square equals 1. The foci is located at plus minus ae comma 0. Isn't it? Okay, so then let's use them. Part B. So focus of foci. Okay, so they say it passes through the focus of the ellipse for which x is greater than 0, which means it passes through the positive. So I don't need to go write both plus minus, right? Okay, so focus of ellipse where x is positive, where x is greater than 0 should be ae comma 0, isn't it? So I just showed it to you from the formula book as well. It's ae comma 0. Got it? Okay. So now focus of ellipse is ae 0. Now what do we know? We know that this particular line, the equation, the line L passes through this ellipse. So immediately what do we feel to do here? Yeah? Yeah, what can we do here? We can substitute the coordinates of the ellipse into the equation of the line, because the line passes through this point. If the line passes through this point, we can substitute these coordinates into the line, the xy coordinates. Okay, because if it passes through the point, we can definitely substitute. Okay, let's substitute. So, since the line passes through the ellipse, the focus of the ellipse, since the line passes through the focus of the ellipse, we can replace bx sec theta minus ay tan theta equals ab, and since the line passes through the point, I can replace the x with ae and y with 0. So what do I get here? B x is ae sec theta minus, of course, if y is going to be 0, a is 0 tan it means the entire term is a 0. Multiplying by 0, everything is 0. Equals AB. Do you agree with me? So what do I get here then? ABE sec theta equals AB. I can actually cancel out AB, right? E sec theta equals, because if I divide both sides by AB, you can see AB cancels out and I get E sec theta equals 1. E sec theta equals 1. Sec is 1 over cos. Sec is 1 over cos, and I get E equals cos theta. So I get E equals cos theta. Now what? Now the question is what? Now they are asking us to show that the line L is parallel to the line y equal x. Okay, now only I am reading the question. Show that line L is parallel to the line y equal x. How do we show that this line, that our line L, that we found the equation of our tangent is parallel to the line y equal x? How do I show that my line is parallel to y equal x? Parallel lines have the same gradient. So what's the gradient here? Y equal x means gradient is Gradient is 1. So all I have to do is, I think I got the gradient here, right? The gradient of the line L is b sec theta over a tan theta. So if I can prove that b sec theta over a tan theta is equal to 1, then the lines are parallel. Isn't it? If I can prove that b sec theta over a tan theta can become equal to 1, that's it. Okay? So I want to show that b sec theta over a tan theta becomes equal to 1. How do I do that? Now I already got one relationship here. Cos theta is going to be E. Okay. What else can we do? We need to work out this value, right? B sec theta over a tan theta. Now the thing is, you have an unknown value b here. Now things need to cancel out, isn't it? We need things to cancel out in order to get 1 here. Okay? So actually what I mainly need here is, I need some kind of a relationship between what? To cancel out b and a, because I can't have b and a here. I need to remove it. I need to get it cancelled out. So what do I do? Yeah, we have our relationship for the ellipse, right? What is it for the eccentricity? Also there was an equation. Yeah. So eccentricity for E, you have here for an ellipse, b square equal a square 1 minus e square. You can go with this equation, isn't it? B square equal a square 1 minus e square. Shall we go with that also and just substitute what we know so that we can get some kind of a relationship between a and b? The eccentricity equation is b square equal a square 1 minus e square. Is this okay? Shall we just replace with what we found? What did we find? We found that b square over a square 1 minus e is cos theta. 1 minus cos square. Who is 1 minus cos square? Sin square plus cos square is 1. 1 minus cos square should be sin square. Guys, are you okay with it? This is the simplest, the smallest identity we learn in P1, right? P1, P2. So 1 minus cos square should be sin square. Okay? So which gives me what? B over A is, I need a relationship for b over a, right? B square over a square is sin square. I can remove the square and get b over a is sin theta. Okay, I can get b over a is sin theta. Do you agree with me? Then shall we go for the gradient now? Try to simplify. The gradient of line L. Because the question is to prove that that our line L is parallel to y equal x. So now we need to keep the end goal in mind. What is the end goal? The end goal is that you want to show the gradient becomes equal to 1. Y equal 1x. We need to show the gradient becomes 1. So what I do is, I get here gradient of line L is b sec theta over a tan theta. I think we need to simplify the second tan now, shall we? So I will keep here b over a. Okay, sec theta is 1 over cos into 1 over tan theta, right? Wait, let me do like this. B over a sec theta into 1 over tan theta. Is it okay if I break it up like this? Because it's the same thing, right? B over a into sec theta into 1 over tan theta. Okay? And then what? Yeah, now let's simplify. B over a sec theta is 1 over cos and tan is, 1 over tan is cos over sine. Because it's 1 over tan. Tan is sine over cos. 1 over tan is cot, which is cos over sine. And what happens here? You can see cos cancels. Okay, and b over a, we just found b over a is what? Sin theta. So we replace b over a with the sin theta into 1 over sin theta. And then we get the gradient as 1. And then what can we see? Just give the conclusion. Therefore, line L is parallel to the line y equal x. That's what we were supposed to show. Yes. Yes. How did I decide? What? Order in the sense? What do you mean? Yeah, this is actually not the strict order. Now the way I've done here, Doesn't mean this is the strict order. You mean to get the gradient 1, you can go in a different way, you mean. You found the E. Okay. Okay. Okay, so I'm just checking some of the working here. E equal. No, you can't remove the square here. That is wrong. E square equal 1 minus b square over a square. You can't remove the squares from everyone in the way that you have shown me. That is wrong because there is a subtraction in the middle. Okay? You can't remove that. That is wrong. So we'll go like this. Yeah. The thing is, I just got the e-value here because the thing is, I just went in the order that makes the best sense to me. So what I did was because they gave me the equation of the line and they told me the line passes through this the focus of the ellipse, I knew immediately I had to substitute x and y into the equation of the line. So I immediately substitute x, y into the equation of this line and I got a relationship for E. I got E in terms E is equal to cos theta. And then I replace that E value into the eccentricity equation. Yeah. Okay, so the people who are watching, if you have any questions, you can ask from me. I'm looking at the chat. Okay, so I'm just giving a minute for the people who are with me to write down. So they are writing down the tech method now. If you have any questions, you can ask. All good, okay. So I'm looking at the chat here. Okay. Shall we? Ryan is still writing, right? Okay, then we'll go for the next one. Shall I go for the integration question or are you good with it? Yeah, question number 7, again in the same paper. Yes, Lahiru, you can talk with me. Shall I do this question? We'll do it, right? Again, it's the June 2017 paper. Okay, so let's go through this. Let's try to do this integration. Okay, what technique are we going to use to perform this integration? What technique are we using to perform this integration? So you have to integrate 5 plus x over root 4 minus 3x square with respect to x. Okay, so how do we perform this integration? Yes, tell me, give me your ideas. Because I will just directly be giving you the answer. Here to use what? Let me take the rules for integration. Yeah, so these are the integration rules that you need to know, right? So these are taken from your textbook. Okay, we don't need this one yet. Okay, so these are the rules. I've just taken this from your textbook. Okay, how does this work? Okay, so let's go for the integration now. How do we integrate? first, yeah, you can't take 5 plus x out of the integral sign. You have to, what can we do here? Now you can see I have several rules of integration here, but all these rules, they need to work with what? You can see that we don't have a x term in the denominator. There's a 1 in the denominator. So what can we do? We can first separate. The first thing we do is we separate. Okay, so when we separate, what do I get here? 5 over root 4 minus 3x square with respect to x, and then plus x over root 4 minus 3x square with respect to x. Can you see? I just broke this into 2. Yes. You want to break it as 5 plus x into, like this, 5 plus x into 1 over root 4 minus 3x square. How does this help you? How will this help us to perform the integration? The thing is, are you trying to go with integration by parts? No, this is the best way to do it. Just split it and we can directly go for the integration. And now what? So 5 over root 4 minus 3x square. So I think you can see over to do this particular question. Okay, you need to we need to have it in this format, right? So which format, which rule are we going to use? Root a square minus x square, the one with arc sign. Okay, so root a square minus x square, but we need to have x square alone. So we'll take this 3 out, shall we? So 5 over, I'll take a 3 out, which means you take a root 3 out. Guys, are you clear with that? You take a 3 out from the root means you don't just take a 3 out, but you take a root 3 out. And then inside the root you get, you are taking a 3 out means you are dividing here, it's 4 over 3 minus x square. Okay, because I'm just trying to replicate this look here. Okay, these are the rules that you are given. Okay, these rules are actually there in the formula book as well. Okay. Okay, so this we can definitely go with this part by using these rules, but this is going to be another challenge. This is going to be a completely new challenge. How are you going to integrate this? Okay, we'll do one problem at a time. We'll tackle one problem at a time. Okay, so how do I first, let's first tackle this problem, the first one. The first problem is this. Now, have I done everything according to the rule? According to that rule, what I can do is to replicate this. Look, you know, you can take constants out of the integral sign, right? You can take 5 and root 3 out because those are constants. So there you can bring constants out of the integral sign, there's no problem. So 5 comes out, over root 3 comes out, integration of 1 over root 4 over 3 minus x square. Guys, are you following me? Okay, so I'm just trying to replicate this look exactly. Okay, then let me finish integrating that part and come to this problem. Okay, how do I do the integration? I can perform this integration now directly, right? So how does it work? Arc sine x over a. Who is my a value here? Who is my a value here? You know, this is the a square, right? This is the a square, which means according to this rule, root a square minus x square, 4 over 3 is my a square, which means a is root 4 over 3, which means a is root 4 is 2 over root 3. Guys, do you find x over a is 2 divided by root 3? Are you with me? Arc sine x over a plus the other part I have still not performed the integration. I'm yet to do it. Okay, now of course I'm just doing it one by one so that it's easy for me to explain, but over in the exam you can do all these things together. Okay. And then this guy, of course, x over 2 over root 3, the denominator root 3, you can bring it up. So you have root 3x over 2. Is that okay? You have root 3x over 2, 5 over root 3, arc sine root 3x over 2. Okay, now the thing is I have to fix the other guy. How do I fix the other guy? In the sense, how do I integrate this? Sorry, not 4, it's x over. I'm sorry, this is x over. Okay, what technique am I going to use to integrate this? Can I take x out by any chance out of the integral just because I want to make the up one? No, you can't take x out of the integral sign. Okay, so the rule that you are going to use is none of the rules here will work, because these rules work as long as you have a constant in the denominator, in the numerator. The numerator constant, we can take it out of the integral sign without any issue, but you can't take an x term out of the integral. The integration happens with respect to x. All x terms are supposed to be inside the integral sign. Yes, Lahiro. So what rule are you going to use? Yes, it's the reverse chain rule, the rule you learn in P4. Basically, this is to perform this integration, we are going to go with a P4 technique. So what is the P4 technique that we go with? In P4 you learn this rule, the reverse chain rule. What is it? F dash x into fx to the power n. So if you have it like this, where you have now fx could be with any power, the n value could be anything. But you need to have the perfect differentiation of this in fx outside over here as f dash x. It needs to be perfectly there. If it's there, you can perform the integration and write the answer directly as fx to the power n plus 1 divided by n plus 1 and then plus c. This is the rule that you learn in P4. Yeah? First to take the root and... No, you can't. Because there's a product here. You can't do what we did here. Now the question is, can I did what I did over here, can we repeat it over here by taking x into root 1 over, you mean like that, right? To break it into 2. The thing is, it's a product here. So you can't apply this rule when there's a product. You mean you're asking me to try something like this, right? X times 1 over and then try to integrate both parts separately. You can't do that. You can't, because it's a product. You don't integrate x separately and this separately. Then you have to go with integration by parts. Okay, don't go for that, because we have a much more easier rule. We will go for the easy rules. There are limits in this question. Okay? So then I will not go like this. We will go with the reverse chain rule. So to apply the reverse chain rule, what's the requirement? You must have the perfect differentiation outside. Okay, and then the other thing is, let's bring the denominator. Let's bring it up, because we need to have it on top in the numerator. The power can be anything. It doesn't matter what n is. Okay, regardless of what n is, as long as you have the perfect differentiation inside, over here, outside, if you can have it, then you can go for the reverse chain rule. Okay, regardless of the power. Okay, so let's go ahead with this. So x stays root 4 minus 3x square. When you bring it up, it's going to be 4 minus 3x square to the power minus half, because it over in the denominator it's plus half. Bring it up, it's minus half. Okay? And now what? And now what? Do I have the perfect f dash x? So this is my fx and this is the n. Do I have the perfect f dash x? What's the differentiation of 4 minus 3x square? Minus 6x. Minus 6x. So you can see the crucial element x is there. What are we missing? The most important thing is x is there. You can't input x, right? But you can input constants. So you can input a minus 6 here to make the perfect f dash x, and if you input a minus 6 to reverse the effect, you input a minus 6 here to create your f dash x. To reverse the effect, we put a minus 1 over 6 outside, so that it does not create any difference to the sum. So we don't do any difference to the sum, and this is your f dash x. Okay? This is your f dash x. And now what? So I have the perfect f dash x, fx to the power n now. Got it? So I will write here, this part is 5 over root 3 arc sine root 3x over 2. I'm ready to perform the integration over here. This is going to be minus 1 over 6, and what's going to happen here? Fx to the power n plus 1 over n plus 1, right? Minus 1 over 6 into, now let's do the integration. All you have to do is just add 1 to the power of your fx, this fx. So just add 1. 4 minus 3x square is there. You add 1 to the power minus half, you get plus half, right? Divide by half. And don't forget the plus c. Simplify this simplify this and try to make your answer, give it in the simplest form. 5 over root 3 arc sine root 3x over 2 minus 1 over 6 into, not into actually, 1 over 6 divided by 1 over 2. It will be 1 over 3. 4 minus 3x square to the power half plus c. Guys, are you okay with this? Is all good? Do you have any questions to ask from me? Okay? Y'all are clear, right? Then I'll move on to part B, right? Okay, I'm just looking whether there are any questions in the chat. Okay, you want to see the question again. B part. Okay, so I'll do part B now. Okay, part B, hence find the exact value of the integration of 5 plus x over root 4 minus 3x square. The limits are from 0 to 1. Okay, so I think we have already performed the integration. All you have to do is what? Substitute the limits. We have already done the integration, just substitute the limits. Part B. So 5 plus x over root 4 minus 3x square, limits are from 0 to 1. Okay, so I have here the answer. This is the integration answer is 5 over root 3 arc sine root 3x over 2. 5 over root 3. This is the answer from part A, arc sine root 3x over 2, and then minus 1 over 3, 4 minus 3x square to the power half. Do I need to put the plus c when I am going to input limits? Do I need to put plus c when I am inputting the limits? No, we don't need to put the plus c. All you have to do is just put the limits where 0 to 1. Input the limits from 0 to 1. So how does it work then? 5 over root 3, let's input the first limit as 1, arc sine, directly it's root 3 over 2. Minus 1 over 3, 4 minus 3 into 1 square, that's actually going to be 4 minus 3 into 1 is 4 minus 3, that's 1. 1 to the power half. Okay, that's the first one, minus, a compulsory minus in the middle, and replace all the x values with 0. So what do you get here? I think arc sine 0 will be a 0, right? Anyway, I will just write there 5 over root 3 arc sine 0 minus 1 over root 3, 1 over 3 minus 1 over 3 into 4 minus 3 into 0 is a 0, so 4. It's 4 to the power half, which is just 2. Are you with me? Okay. Can I know the value of arc sine? So definitely calculator should be in radian mode. In radian mode, what do you get for root 3 over 2? Pi over 3. Sine inverse. Arc sine is sine inverse, directly, trigonometric, okay? Just type normally in the calculator sine inverse root 3 over 2, which is pi over 3. And you get here minus 1 over 3 into 1 to the power half is 1 over 3. 1 to the power half is simply 1, so it's just 1 over 3. Minus, this guy will be 5 over root 3 into arc sine 0 is a 0. So we don't even need to write it. We could have just directly put it as 0 at the beginning. Here minus into minus. Be cautious here because of the bracket. Minus minus should be plus 2 into 1 over 3. Yeah, it's 2 over 3. So when you add everything, I get here 5 pi over 3 root 3 minus 1 over 3 plus 2 over 3 is plus 1 over 3. I think in the show that, yeah, the root 3 is up, right? Which means we should rationalize. Yeah, so you rationalize, which gives you 5 root 3 pi over 3 root 3 into root 3. That's 3 times 3, 9. Plus 1 over 3. Yeah, so we get this. Okay. That's the answer, yeah. So giving you answer in the form p pi root 3 p pi root 3 plus q. So 5 over 9 pi root 3, yeah, plus 1 over 3. Okay, are you all clear with this? Dolashika, Lahiru, can you all speak up?
Yeah, ma'am.
Yes. Okay. Then let's go for the next one, right? So if there are questions, you can request. Okay, so I'll go for the next one. Okay, we'll try this one as well. This is again from June 2017. Okay, we'll try this one. I think that now again to do these kinds of questions, you can't just do it. You need to know what? The relevant. You must know the relevant formula, because to do these certain kinds of questions, now they say here the curve C has parametric equations, x, y is given. And can you see this one? The curve C is rotated through 2 pi radian about the x-axis. And they ask you to find the area of the curved surface. So to do this, you must know that there are certain equations to use. I think it's there in your formula book also, right? So if I show you the formula book, now they say the curve C is rotated through 2 pi radian about the x-axis. The area of the curved surface generated is given by S. Show that S is equal to this equation. How do we do it? So either you need to remember or it's there in your formula book. So this is the formula book, I think. Yeah, this one, right? Can you see? So this is your formula book, and I'm just turning this to the arc length, and the surface area of revolution is given. Now, which equation? You can see the one equation is with respect to x, which is Cartesian. The other equation is with respect to t, which is parametric. Now, are we dealing with parametric equations here or Cartesian? Look at this. The curve C has what? The curve C has parametric equations. So you are dealing with parametric. Okay, so not parameter t, but parameter theta. So all you have to do is go through this equation. Okay, it's there in the formula book. Just it's not dt, it's going to be d theta. So it's going to be 2 pi integration y dx by d theta square plus dy by d theta square with respect to d theta. And your limits should also be what limits? Your limits must be theta limits. Are you with me? Okay, let's first apply this rule. Okay, let's first apply this rule. So you must first know that this rule exists and that you have to apply this rule in order to get the show that. That's the first thing. Okay, that's the first thing. Okay. Can you all repeat the rule to me again? S equals 2 pi integration sign y, and there was a root dx over, now we will change this into the context of our sum, okay? Dx over d theta whole thing square plus dy over d theta whole thing square. D theta. So it will be theta limits. Got it? Okay. So now let's, obviously I have to get the dx by d theta value, I have to get dy by d theta. So first I should find those guys. Okay, let's get them. So I have x equals theta minus sine theta. How do I get dx by d theta? I have to obviously differentiate. Okay, so when I differentiate, what do I get? dx by d theta equals, theta differentiation is 1 minus sine differentiation is cos. So dx by d theta is 1 minus cos theta. Is that okay? Then let's go for dy by d theta. What do I have for y? Y equals 1 minus cos theta. Y equals 1 minus cos theta. Now what? dy by d theta is equal to, so 1 differentiation is 0, sine, cos differentiation is minus sign. There's already a minus mark outside. So cos differentiation is another minus. So that gives you directly just sine theta. Okay, so you need to remember these are small stuff to remember. Okay, now Let's take all of these things and substitute them to this equation, shall we? Okay, let's substitute the values. What do we get over here? S equals 2 pi integral y. So shall I replace the y value also directly? Y is going to be 1 minus cos theta. This y over here, I'm going to replace 1 minus cos theta, and then it's the root dx by d theta square. Dx by d theta is 1 minus cos theta square plus dy by d theta is sin theta. So sin theta whole thing square. Yeah, sin square theta. Yeah, basically sin square theta. Okay. Okay, and now what? Okay, and now what? Let's simplify. We have to get this show that. Okay, so obviously your theta limits are going to be what? You don't need to input. I mean, you can clearly see the theta limits are given to you from where to where? 0 to 2 pi. So limits are, you can directly take the limits from the sum. It's given to you. Limits are, theta limits are 0 to 2 pi. Okay, then let's go for the answer. S equals 2 pi times 1 minus cos theta. How do we simplify this? Now the thing is, the show that also involves 1 minus cos theta. So if I have 1 minus cos theta, just because always we need to keep a lookout for the show that. Show that has 1 minus cos theta. So if you have 1 minus cos theta over here, I will try my level best to not to, not to open. Now I would not prefer to open this and try to simplify. Let's keep it like this, because I show that also has 1 minus cos theta, right? So we'll try to do something about the sine square theta. What can I do for the sine square theta? I think we'll have to open, right? Sine square is 1 minus cos square theta. Okay, actually even if it go like this, no, we are going to get stuck, right? I think we'll have to open the bracket. Yeah, we'll have to open the bracket. Let's open. We'll have to open. No, it doesn't work. We'll open this bracket and then things might simplify out. Let's open the bracket. 1 minus cos theta square is going to be 1. Then twice of 1 and minus cos theta is minus 2 cos theta. Are you all with me? And then plus cos square theta. And over here you have plus sine square theta. Okay. Now what happens? What do you see here? Do you see something that that can simplify here? Cos square plus sine square. Sine square plus cos square is 1. So you have 1 here. This guy is going to be 1. So ends up giving you what inside the root? It's going to be inside the root. This is a 1 plus a 1. 2 minus 2 cos theta. Do you agree with me? And now you can take 2 out. Basically, if you take 2 out, you can take it out as a root 2. Take it out as a root 2. So I can take a root 2 out, and root 2 is a constant which can even come out of the integral sign. It can even come out of the integral sign, because integral sign is with respect to theta. So the others can all come out. So because I have taken root 2 out, it will be 1 minus cos theta to the with the root or power half. Okay, and now the last step to get the show that. Same base, right? So same base, root 1 minus cos theta is 1 minus cos to the power half, and here it's 1 minus cos to the power 1. So when you are multiplying same base, powers are added. So I get here, how does the show that look like? 2 pi root 2. Yeah, and you can directly write 1 minus cos theta to the power 3 over 2. Can you see how I get 3 over 2? Because root means a power half. Power half and power 1, when you add, it's 3 over 2. Yeah, and limits are 0 to 2 pi. I think I just have to continue the limits here. Okay, guys, are you clear with this? Okay, is this clear?
Yes, ma'am.
Okay, then let's go for the next part. Okay, next one, part B. I think you can see now always when you are looking at questions, always look at the number of marks they give to the question, because the number of marks will let you decide how much time you actually should spend on that question. The number of marks will tell you how much time you should spend on that question. So now what? So now what do? They are asking you to get the exact value of s, which means they want you to perform this integration. They want you to perform the integration, and you can see how many marks have they allocated for the integration alone. The integration alone has 6 marks. Okay? So which means this should be quite a challenging integration. Okay? So I want you all to give me some ideas here. How do we perform this particular integration? I want your ideas entirely. So rather than just giving the answer, I want to hear something from you all. Yes. Tell me, how do I perform this particular integration? How do we go ahead with this integration? You already have some kind of a power, 3 over 2. So none of the normal rules we learn, they don't work with these kinds of powers. So what do we do? What do we do in order to perform this integration? Yeah, this is like a quick revision for the exam tomorrow, right? Your F3 exam is tomorrow. So this is just to, give you guys a quick revision and like do some difficult questions. Yeah. Okay, now I'm asking you for a technique. How do we perform this integration? So it's 6 marks. Yeah. Okay, so yeah, guys, any tech now? I have people who are with me over here, right, seated right next to me, and I have a few more people who are joining online, and I have a few more people who are joining from YouTube, right? So anyone, I just want any of these people to just give me some kind of an idea how to perform this integration. Tahiru, you're joining online, right? Yes. Tell me, how do you have any technique here that you could suggest to perform the integration? Yes.
And we could use by parts then for this.
By parts. How do we go with by parts? Integration by parts. Now I want your ideas, because I can just give the answer which is going to be too easy then. Substitution. Okay, there are different things people are saying. Integration by parts, integration by substitution. Actually, the thing is this. If this question was presented slightly differently, listen to me. If this question was presented slightly differently, you guys would all be able to do it without any issue. It's just the presentation of the sum that's making you confused here. If I ask you, now let me say like this. Let me give you an idea, let me give you a hint. What if you have to integrate 1 minus cos 2 theta to the power 3 over 2? What would you do? If you had to integrate 1 minus cos 2 theta, what would you do? You would apply double angle rules, right? And what double angle rule is the most appropriate? The one that can, now there's a power also, right? So, cos 2 theta has 3 equations. What are 3 equations? Cos square minus sin square. Other than that, we have 2 cos square theta minus 1 and 1 minus 2 sin square theta. I'm just taking a small detour here. I'll come back to this. But if I give you this sum, now let's say this was the sum, you would immediately, your mind would go to the double angle rule, isn't it? And then you would try to obviously use out of these two, which one is the advantageous rule to use? Which of these two rules is the more advantageous, and first one or second one? Use the rule that will help you to what? Cancel out this 1. Use the rule that will help you to cancel out the 1. Which one is it? Because remember there is a minus mark outside. Which one is it? The second one, right? Because it's 1 minus cos 2 theta, you have to put it inside the bracket. 1 minus 2 sine square theta. Can you see? Just be cautious here with the brackets. Can you see? And power 3 over 2. Then when you expand the bracket, you get 1 minus into 1 is minus 1, minus into minus is a plus. 2 sine square theta, power 3 over 2. Can you see? And then the plus 1 minus 1 can cancel out. And you have integration of 2 sine square theta to the power 3 over 2. Yeah, and then you get here 2 to the power 3 over 2 and sine square theta to the power 3 over 2. Obviously the powers will multiply. So sine to the power 2 with 3 over 2, when you multiply, you will get sine cube theta. Are you with me? You get sine cube theta. So you can come to this particular stage, right? Okay, so then let me go back to this sum and then we will go for integration of sine square after the sine cube after that. Okay, so can't I use a similar technique? Can't I use a similar technique over here? How do you say, okay, how do I go with that technique? Tell me. So it's cos theta. If it, now you know the double angle rule, it doesn't only work for 2 theta. It can work for 3 theta, it can work for 4 theta. As long as you take half the angle here to the other side, it works perfectly for any angle. So which means what?
If we use 1 minus 2 sine theta over 2.
Exactly. Exactly, half theta. So you are going to replace, instead of cos 2 theta, we are going to have the same rule. Instead of cos 2 theta, I am going to use cos theta. And if it's cos theta, the other side I should have half of the angle. That's why it's called double angle, half angle rule. So it's going to be 2 cos square. Sorry, I will use the second rule, right? I'm going to use this one. Okay, so it will be 1 minus 2 sine square what? Half theta. Guys, can you see that I am actually using the cos double angle rule? Instead of working with 2 theta, it's just 1 theta. So the half of 1 is half theta. Shall we use that over here now? Shall we use this over here? Are you with me? Okay, let's go for the integration then. How does it work? 2 pi root 2 integration of 1 minus, show all the steps. I was just doing something to show you how it works for 2 theta. So show all the working here. Cos theta is 1 minus 2 sine square half theta. Okay. And this is outside, there's another bracket with the power 3 over 2. So don't forget the power 3 over 2. Okay. Okay, now what? It cancels. You can expand and simplify inside. 1 minus 1 into 1 is minus 1. So it's going to be 1 minus 1. Minus into minus is a plus. It's going to be plus 2 sine square theta over 2, half theta. And then outside there's a power 3 over 2. Do you agree with me? Okay, now the plus 1 and minus 1 will completely cancel out. The plus 1 and minus 1 completely cancels out. Okay, and now what? I have 2 pi root 2 and 2 pi root 2. I have 2 to the power. So the power 3 over 2 goes to both these functions, right? 2 and sine square theta over 2. So you get here 2 to the power 3 over 2 times sine square theta over 2 to the power 3 over 2. The powers multiply and you get sine cube theta over 2. Do you agree with me on that? 2 to the power 3 over 2, we can take it out. 2 to the power 3 over 2 because it's a constant. 2 pi root 2, actually who is 2 to the power 3 over 2? Now if you type in the cal 2 to the power 3 over 2, I believe you will get decimals, right? So you should know how to simplify something like 2 to the power 3 over 2 is actually what? 2 to the power 1 times 2 to the power half. So you should know 2 to the power 3 over 2 is actually what? 2 root 2. So these are small things that makes a big difference, so you should remember those stuff. So 2 to the power 3 over 2 is 2 root 2. Okay, and inside the integral sign you have sine cube to the power, sine to the power 3, sine theta over 2 to the power 3. Okay, now what?
We could split the sine cube to sine theta over 2 and sine square theta over 2.
Okay, so So Lahiro has an idea. Let's split the sine cube theta as sine theta over 2 and sine square theta over 2. Okay. So let's split it up. Okay. So I get here 2 root 2 into 2 root 2 gives me 8 pi. Sine cube theta over 2, we can break it as sine theta over 2 times sine square theta over 2. Okay, now what? After this step, what's the next step? Now what? Yeah?
1 minus cos square.
Sine square is 1 minus cos square. Okay. Sine theta over 2. Sine square theta over 2 is 1 minus cos square theta over 2. Okay, and then the next step is what? You can expand this, right? Sine theta over 2 into 1 and sine theta over 2 into cos square theta over 2. Let's expand the bracket. So what technique is there in my head? Why am I doing this and what technique am I like planning to use? Do you see? Can you see what technique I am planning to use here? Minus this is sine theta over 2 into cos square theta over 2, right? So I think you can see sine theta over 2, we have absolutely no problem in this integration. It's just sine. We know how to integrate sine with the coefficient. This is perfectly fine. What is the problem? How do we integrate this guy? So this, again, we can use the reverse chain rule. Reverse chain rule is what we are going to use here. The reverse chain rule, P4 rule, how does it work? You have f dash x, fx to the power n. Regardless of whatever the power you have here, regardless of what you have for n, as long as you have the differentiation of the fx inside fx outside, if you have it perfectly, you can perform the integration as fx to the power n plus 1 over n plus 1. Okay, so as this is the reverse chain rule. This is something you learn where? In P4. Okay, so that's what I'm going to use here. Sine theta over 2 is alone. Absolutely no, there's no problem in that integration at all. Okay. So I'll keep 8 pi over here. Sine theta over 2, when I perform the integration, it's going to be, you know, sine ax plus b. Do I need to take the rules? You know how sine ax plus b integrates, right? Sine ax plus b integration is 1 over a cos ax plus b. Is there a minus sign involved? Sine integration, do we have a minus? Yes, there is a minus involved. So you need to go through the rules. Sine integration is negative cos, right? Yes, sine integration is negative cos. Okay, P3, P4. Okay. Okay, sine integration is negative cos. So it's going to be, by the way, you have half theta, which means what? Which means it's going to be 1 over that half, right? 1 over a, because if you have sine ax plus b, it's minus 1 over a cos ax plus b. Okay? So if you want me to show the rules, let me know. I'm just directly using the rules. I have all the integration rules written. Shall I show it? Okay, so these are all the integration rules. Can you see? I've just written the general format of the P4 rules that you learn, P3, P4 rules. So this is the where sine ax plus b integration is minus 1 over a cos ax plus b. Can you guys see? Okay, so let's go with that quickly. So it's going to be, there's a minus 1 over a is this half x, half theta. So you divide by half, and it's cos theta over 2. Over here, you need to be really cautious. It's cos square theta over 2 means you need to realize that this is your fx, right? The power 2 is outside. Can you understand? I just removed this power 2 and I put it outside. Okay, so this is the fx. This is like your fx. I think we need to fix this over here, right? Wait, shall we fix it first? Wait. Let me do it again over here because we had to have the perfect f dash x. I don't have the perfect f dash x. Can you see? Okay, let me do it like this. I have already done this integration, right? I have already performed the integration here. Over here, I have not yet performed. Can you see? I'm using the integral sign here because I have not yet performed it. Sine theta over 2 cos theta over 2 to the power 2 d theta. Can you tell me what exactly is missing here? Because you have here fx, the differentiation of cos is, what is missing here? The differentiation of cos is, because you need to have the perfect f dash, meaning the inside differentiation, the differentiation of the in function should be perfectly there outside. So cos differentiation is minus sine theta over 2 into another half. So what exactly is missing here? There are a few components missing. When you differentiate, it's minus sine theta over 2 into differentiation of half theta is half. So you are missing the minus mark and the half for the f dash x. So then we need to input a minus mark and a half. If you input a minus half in, you have to write outside what? A minus 2 over 1, so that you don't, there's no difference to the sum. Because you are inputting a constant, you need to make sure that you can't just input a constant out of thin air. So what do you put here? You need to make sure you counteract that effect by putting it outside. So that in end of the day there is no difference to the sum. Minus minus makes it a plus again. 2 cancels. So I have not done any difference to the sum. There's absolutely no difference in the sum. Okay, so I get here. I think now I have the perfect f dash. Is it? Okay, so we'll go now. So 8 pi, this part I have already done the integration. 1 over half is 2 cos theta over 2. Are you with me? This is a minus minus plus 2 over 1, and then let's perform the integration. How does the integration work? Perfect f dash x with f theta, fx to the power n. You have to add 1 to the power of your fx and divide. So this is going to be cos theta over 2 to the power 3 divide by 3, because you have to just directly follow the rule. You don't need to put any other coefficients or anything like that. Just go with the rule. And there are no limits, which means you must put, are there limits? By the way, 0 to 2 pi. There are limits. Yeah, 0 to 2 pi. So limits are 0 to 2 pi. Let me simplify this slightly before I go for the limits. 8 pi times minus 2 cos theta over 2 plus 2 over 3 times cos cube theta over 2. Guys, are you clear with this? So now let's go for the limits and get the final answer. This is a show that, by the way. No, hence find the exact value, 6 marks. I think you can see why it's 6 marks. Like it's a lot of hard work over here. The amount of simplification, it's a lot of thinking. So you need a lot of, you need to practice a lot of sums, right, before going to the exams, because it's going to be hard to think of this like immediately. Okay, let's simplify and let's substitute the values. Minus 2 cos 2 pi over 2. I just replaced theta with 2 pi, okay? Plus 2 over 3 cos cube 2 pi over 2. This is the first limit. Minus, let's go for the second limit. The second limit is you replace all the theta with 0. Replace all the theta with 0. You get minus 2 cos 0. I'll just not bother to write the divide by 2. It's just going to be 0. Plus 2 over 3 cos cube 0. Isn't it? Yeah. So can I have the simplified answers? Tell me the answer. Cos 2 pi over 2, so it's going to be cos pi. Cos pi is minus 1. Minus 2 into minus 1 is a plus 2. Agreed? Cos cube 2 pi over 2. Again, it's cos cube pi. Cos pi is minus 1. So cos cube, minus 1 to the power 3. Minus 1 cube is minus 1, which is minus 2 over 3. Are you all with me? And over here, it's going to be cos 0 is actually going to be 1, right? So this is 1. And this is also 1. So I end up getting minus minus is a plus 2. And minus into plus is minus 2 over 3. Guys, are you with me? Okay, this plus becomes minus into plus is a minus. So I end up getting here 8 pi times 2 plus 2 is 4. Minus 2 over 3 minus 2 over 3 is minus 4 over 3. Whole thing inside the bracket is 8 over 3. Yeah, so 8 pi times 4 minus 4 over 3 is 4 times 3, 12. 12 minus 4, 8 over 3. So 8 pi into 8 over 3 is 64 pi over 3, which is the final answer. Okay, so quite a tough simplification, and especially you need to do this particular sum. You need to really kind of like understand that you can use double angle rules even for a cos 1 theta angle. You can use double angle rules. It doesn't matter. It doesn't have to be 2 theta. It doesn't have to be 4 theta, because we are so used to using double angle rule when it looks like this, right? But we do not. It's quite rare that you think of double angle rules when you see like this. But anyway, without going through this particular technique, it's going to be difficult to integrate. Okay. So this is a really good sum from the June 2017 paper. Quite a challenging sum, right? So makes you think a lot. Okay. Are there any questions? Yeah, Ryan? What about Lahiru? Tulashika? Yeah, and everyone in YouTube, if you have any questions, you can, send it on the chat. I'm keeping an eye on it. You can, ask any questions related to this. Okay, so shall I just move on now? I'm just waiting to see if there are any comments or anything you need to ask. Then we can move on to the next question. Okay, guys, are you clear on this? So I'll move on, right? Because the thing is, if you have any specific questions related to this integration that I performed, you can, you can ask me. Okay. I'll move on. If you have anything, you can just let me know. Shall we do the last question as well? It's a vector question, right? Okay, it's a vector question. Shall we try this? Okay, let's try the vector question. Okay. Question number 9. This is also again from the same paper, June 2017. Okay? Shall we try this? Okay, question number 9. With respect to a fixed origin O, the points A, B, C and D are the vertices of a tetrahedron. Do you remember a tetrahedron in the F3 book? So you learned how to find the volume of a tetrahedron. So can you all just remind me of the equation for volume of a tetrahedron? Volume of tetrahedron. So they are specifically, it's given to you in your textbook. 1/6 volume of a tetrahedron. 1/6 modulus A dot B cross C, right? Okay. So B cross C actually gives you the area of the triangular base, and then when you take it with the A dot, you get anyway when the scalar triple product gives you the volume, right? Just A dot B cross C gives you the volume of a parallel pipe. 1/6 of A dot B cross C gives you the volume of a tetrahedron. Okay, do you recall what I'm talking here? Okay, so if you require any of these theories regarding vectors, you can let me know in the chat, because I have the recorded lessons for vectors and matrices and integration. So the recorded lessons are there. If you require them, you can let me know. Okay. Okay, so these are just the theory part. Anyway, you should be familiar with this theory in order to do this question. Okay. So find the volume of the tetrahedron. So when it comes to this tetrahedron, now what do we use for ABC here? So you have to choose one major vertex, right? One person to be the major vertex. So I will go with A. Okay. So what do we choose here? You can obviously go with, we need for, now if you take your tetrahedron, let me draw it like this. So this is the tetrahedron. So we take one major point as A, isn't it? And then you can go for, you can mark A, B, C, D. I mean, just go with the theory. So you can mark here the plane. So I think I will just read part B. Also, plane contains the points A, B, C, which means I will go with A, B, C down here and D at the top. Okay, and then how do we go for volume of a tetrahedron that looks like this? It will be 1/6 of modulus AD dot AB cross AC. This is how it looks like, isn't it? AB cross AC gives you the area of the triangle, the base, and then you take the cross product with AD, and 1/6 of it gives you the volume of the tetrahedron. Okay? So all you have to do here is now what? You have to get the AB vector, AD vector, and AC vector. Shall we find them? Okay, so A, B, C, D points are given to you. So who is AD? AD is D minus A, isn't it? Okay, who is D? D coordinate is 3, 6, minus 1. Minus A is minus 1, 5, 1. So when you subtract, what do we get? 3 minus minus 1 is 4. 6 minus 5 is 1. Minus 1 is minus 2. Okay, that's minus 2. And then let's go for AB. So AB will be, it will be, AB will be B minus A. Yeah, it will be, so B is going to be 1, 0, 3. A will be minus 1, 5, 1. Okay, so it's going to be 1 minus minus 1 is 2, 0 minus 5 is minus 5, 3 minus 1 is 2. Okay, so the person who requires the recordings, you need to just contact me on the Telegram. Okay, so I think the link to the Telegram group is there in the description of my other F3 videos, I think. Okay, so just send me a message after the live stream is over, and I will let you know how you can access those vectors and matrices recordings. Okay. So 2 minus 5, 2. Okay, that is AB, and then we should also get AC, right? C minus A. Okay, so C minus A will be, who is C? C is 2 minus 1, 2. Minus A will be, who is A? A is minus 1, 5, 1. Okay, so this is going to give me 2 minus minus 1 is 3, minus 1 minus 5 is minus 6, 2 minus 1 is 1. Are you with me? Okay, so 3 minus 6 and 1. Okay, so I have my AD, AB and AC. Are you guys checking on this? Yes. Okay, so now it's time to get the scalar triple product. Okay, how do we get the scalar triple product? Basically, you know, the scalar triple product is the determinant of a 3 by 3 matrix, isn't it? Scalar triple product is the determinant of a 3 by 3 matrix, isn't it? So let's get it. So the first line should be the AD. So I'm gonna get AD dot AB cross AC. Okay. So AD is 4, 1 minus 2. AB is 2 minus 5, 2, and AC is 3 minus 6, 1. Guys, are you with me? So the scalar triple product is the determinant of a 3 by 3 matrix. Okay, so this is plus, minus, and plus. So let's get the scalar triple product. So that will be 4 times, so remove the row and column with 4, it is going to be minus 5, minus 6, 2, 1. Guys, if you can do this immediately, do it. So if you can take the determinant also, I'm just writing the steps so that everyone is clear on what's going on. But what I'm writing right now is not absolutely necessary. It's not required. It's not required. So then in the next one, minus 1, you write, you remove the row and column with minus 1 and write the remaining elements, 2, 3, 2, 1. Agreed? 2, 3, 2, 1. And the next one, you write minus 2 and remove the row and column with the minus 2 elements. So it's 2, 3, minus 5, minus 6. Agreed? 2, 3, minus 5, minus 6. Okay? So this step is not like an absolutely necessary step, but just I wrote it just to be clear. So if you could write with this step, that is more than enough. Okay, so then this is minus 5 into 1 is minus 5, minus 6 into 2 is minus 12. Minus 1 times 2 into 1 is 2, minus 3 times 2 is 6. Minus 2 times 2 into minus 6 is minus 12, 3 into minus 5. Minus 3 into minus 5 is minus 15. Okay, guys, are you okay with what's going on? So then I get here 4 times, what do I get here? Minus 5 plus 12 is how much? 7, right? Plus 7. Minus 1 into 2 minus 6 is a minus 4, right? Y'all can get me the answer. Get me the answer here. Minus 12 plus 15 is plus 3, isn't it? What's the final answer? Is it 26? Yes. 26. Lahiru, is this okay?
Yes, ma'am.
Yes, okay. And then this is not the final answer. The volume is? Yeah, because you have to take the modulus of it. So 1/6 of modulus of AD dot AB cross AC, right? Now the thing is my scalar triple product. Now even if it was a negative, it needs to be inside the modulus. So you have to take the magnitude. So here I'm not having any problem with a negative sign. So all you have to do here is it's 1/6 of modulus of 26, which is simplified as what? Modulus 26 is 26. So 1/6 of 26 is 13 over 3. So this is the volume. Okay? Okay? Is this clear? Okay, and then the next one, part A is done. I hope you guys are okay with it. If there are any questions, just let me know. Okay, then the next one. Okay, so the next one we'll go to part B, right? The plane pi, the plane contains the points A, B, C. Find a Cartesian equation of the plane. Guys, how do we get a Cartesian equation of a plane? What is the format for the Cartesian equation of a plane? Remind me again. Can you remind me the Cartesian equation? R dot n equals to A dot n. Good. You all can remember. Okay, so the Cartesian equation of a plane is R dot n equals A dot n. R represents any point on the plane, and what does n specifically represent? N specifically represents a vector who is perpendicular to the plane. That's really important. N represents a vector who is perpendicular to the plane. Guys, now I want to find a vector. Now this is part B. So there is this plane. It contains the points A, B and C. So then to get this equation of the plane, I need to find n. N is a vector who is perpendicular to the plane. How do I find a vector perpendicular to the plane? So this is where the cross product comes in. Because what does the cross product do? The cross product gives you a vector who is perpendicular to both the vectors that you're taking the cross product of. So basically, I can easily get the cross product of what? AB and AC. I can easily get the cross product of AB and AC. Okay? So AB cross AC. Remember, AB cross AC gives you what? AB cross AC gives you a vector who is perpendicular to both AB and AC, automatically giving what? Automatically making it a vector perpendicular to the entire plane. Because it's perpendicular to both of these guys, it will end up giving you a vector perpendicular to the entire plane. Do you get it? So AB cross AC, I mean I already have AB, the vector found, and I already have the AC vector found. All I have to do is to get the cross product. So when you have two people with cross product, we get the determinant of a 3 by 3 matrix by using the first row as IJK, isn't it? The first row we use as IJK. Then AB is gonna be, we have already found AB is 2 minus 5 and 2. And AC is gonna be 3 minus 6 and 1. Guys, are you okay with what's going on? Okay, and then what? You use plus minus plus and go for the determinant. So this time you'll get your answer in terms of I, J and K. So this will be your N. Remember, this gives you N, a vector who is perpendicular to the plane. You get N here. Okay, so then it's going to be I times plus I times, remove the row and column with I. What do we get? Minus 5 minus 6 2 1. And then minus j times, remove the row and column with j. I remain with 2 3 2 1. And then the next one plus k times, it's going to be, if I remove the row and column, 2 3 minus 5 minus 6, right? Okay, and then let's go here I times, when you take the determinant of the 2 by 2 matrix, minus 5 into 1 is minus 5, minus 6 into 2 is minus 12. Literally, just be really cautious, okay? Next one, minus j times, 2 into 1 is 2, minus 3 times 2 is 6, plus k times, 2 into minus 6 is minus 12, minus 3 into minus 5 is minus 15. Guys, are you okay with it? What do we get here? Minus 5 plus 12 will be plus 7i. 2 minus 6 is minus 4. Minus 4 into minus j is plus 4j. Are you with me? Minus 12 minus means minus 12 plus 15. So that's plus 3k. So this is what? This is our n, the vector who is perpendicular to the plane. Okay, so now we can go for r dot n equal a dot n and get the Cartesian equation. So for r dot n equal a dot n, now r is of course going to be x, y, z, a general point on the plane. But what about a? A is supposed to represent the coordinate of any point on the plane. So for a, you could use either the a coordinate or the b coordinate or c, because it can be any coordinate on the plane. So I'll go with the first one, a. Okay. R is a general coordinate of any point. R represents the coordinate of anyone on the plane. So that is, R is generally, we write x, y, z. Okay. Okay. So over here, okay, so wait, let me finish this. I think I have a question in the live chat, but that question is related to a sum that I did some time ago, right? The sec square question. Let me come back to that after I, finish this question. Let me finish this first. Okay, so what do we get here? Find the Cartesian. Okay, we were in the Cartesian equation. Let's get it. R dot n equal a dot n. Okay, so what's happening over here? R is x, y, z. Dot n is, guys, n is 743 equals a dot n. A is, for a, you can use any coordinate who is on the plane. So I can go for any coordinate on the plane. For a, I will go with minus 1, 5, 1. For a, I will go with minus 1, 5, 1. Dot n is 743. Guys, are you following me? So now dot product, of course, is quite easy, right? Just multiply the x term with x. So x into 7 is 7x. Y into 4 is plus 4y. Z into 3 is 3z. Equals, multiply the other side. Minus 1 into 7 is minus 7. 5 times 4 is 20. Plus 1 times 3 is 3. Do you agree with me? Okay, then I get here 7x plus 4y plus 3z. Can I have the simplified answer here? Minus 7 plus 20 plus 3? 16. Yeah, so this is the answer. This is the Cartesian equation of the plane because they ask you the Cartesian equation. So this is the Cartesian equation. Okay, because Cartesian equation needs to involve what? X, Y, Z. If they ask the vector equation of the plane, it needs to be with the mu and lambda. It needs to be with the R equal A plus lambda B plus mu C, because if it's a vector plane, you remember there are two parameters. So they are asking us the Cartesian equation. That is why I went with this equation, because they wanted the Cartesian equation. Okay, if they wanted the vector equation, I would have taken a totally different approach. Okay. Okay, then let's go to the next one, part C. Part C, they say the point T lies on plane pi. Okay, so the point T, okay, on top of this plane, there's another point called T. Okay, that's another point called T. Actually, you can see ABC, but I have even drawn it over here, right, in part C. Can you guys see what I'm talking about? In part A, the tetrahedron ABC was on the plane, and then D is above that plane, right, to form the vertex of the tetrahedron. Now look at this, because they're talking about D again. The point T lies in this plane, so it lies on this plane. The line DT is perpendicular to the plane. What do you mean by that? The line DT means, now you know D is the vertex of a tetrahedron, because I'm considering ABC on the plane, so D is what I'm considering as my vertex. So they say the dt is perpendicular, which means this is dt. Can you see? Okay, dt is perpendicular. Find the exact coordinates of t. Okay, how do I find the exact coordinates of t? Okay, how do I find the exact coordinates of t? Yes. Very good. I think I have some good answers from here. Yeah. So now the thing is, we need to get the equation of this, not the equation, we need to get the coordinate of this point T. What is point T? Point T is the place when you drop the perpendicular from D to the tetrahedron, they say that dt is perpendicular. So dt is perpendicular in the sense, if I draw this line over here, I think you realize, what do you realize? Sorry. So what do you see here? dt is perpendicular to the plane means, okay, well, how do we get the coordinates of the point T? So I had a correct answer that you said to me. So the technique is that we actually we solve the we go to solve the equation of the plane with the equation of the line dt, because I can see that the plane, now there's this line called dt, right? Now this point T is over here. So d to t, if you drop its dt is like this, right? So if I can find the equation of the dt line and solve it with the equation of the plane, I can find the intersecting point. Because in the F3 book, you have done a theory where you solve where you find the intersecting point between the equation of this line. I need to know the equation of the line dt. Can you all suggest me how I can find the equation of the line dt? How can I find the equation of dt? Guys, yeah? Equation of dt is going to be, I mean, it's a vector equation, r equal a plus lambda b. Let's go for the vector equation of a line. R equal a plus lambda b, where a represents a position vector. Yes, Lahiru?
Ma'am, r equals d plus lambda n, ma'am.
Exactly. Because the thing is, a represents a position vector on the line, b represents the direction vector on the line. So here you can see this line goes through D, and is D a point that we know? Yes, we know the coordinates of D clearly. And B is the direction of the line. Now we know this particular line is what? Perpendicular to the plane. So we have the direction vector who is perpendicular to the plane, n. So then B is going to be n, right? Are you with me? Yeah, n is the vector who is perpendicular to the plane, means dt and n are parallel. dt will be parallel to n. So therefore, because I'm trying to get the equation of the line dt, the direction vector of line dt can be found by n. So d is gonna be 3, 6 minus 1 lambda times n is gonna be 7, 4, 3. Are you with me? So r equals, if you add them together, 3 plus 7 lambda. This is 6 plus 4 lambda. This is minus 1 plus 3 lambda. This is the equation of the line. And then what do? I want to get the cutting point. So I will solve the equation of the line dt with the plane equation. What's the plane equation? We found it now. We just found it in the earlier one. What was it? 7x plus 4y plus 3z equals to how much? Equals to 16. 7x plus 4y plus 3z equals to 16. Guys, now what do? I want to solve these two guys simultaneously, the line and the plane. All you have to do is replace the x with 3 plus 7 lambda. Replace y with 6 plus 4 lambda. Replace z with minus 1 plus 3 lambda. Do you get it? It's quite simple. Replace the x with 3 plus 7 lambda. This is clear. Replace the y with 6 plus 4 lambda. And replace the z with this. That's it. Yes? Because I want to get the cutting point. Because when I solve the question is why am I solving it simultaneously? The reason I'm solving it simultaneously is because I want to get the cutting point. I want to find the intersecting. The intersecting point gives me the what? The coordinate of t. That's what I want. I want the coordinates of t. Okay? So 7 times x is 3 plus 7 lambda plus 4 times y is 6 plus 4 lambda. Guys, can you see what I did here? Let me erase and write again. 7 times 3 plus 7 lambda. 4 times y is 6 plus 4 lambda. Plus 3 times z is minus 1 plus 3 lambda. Equals 16. Are you with me? Open the bracket. 7 times 3, 21 plus 49 lambda. 4 times 6 is 24 plus 4 times 4 is 16 lambda. Are you all with me? And then for the matrices video, just get into my Telegram group. I can see that you all are asking me for the matrices videos. Just get on to my Telegram group. You will find the link in the other videos, in the other F3 videos. Okay, so just get on to that. Then I will give you the instructions how to get it. Okay, because it's posted separately. Okay, so let's complete the sum. I will answer the question for the differentiation question. Just give me a moment. Let me finish this off and then I'll answer the differentiation question. I can see there's a question on the chat. Okay, let me come back to this. So what do I have over here? 24 plus 16 lambda. 3 into minus 1 is minus 3 plus 9 lambda equals 16, right? Guys, are you okay with this? And then what do I get here? Can you add the lambda terms? 49 lambda, 16 lambda, 9 lambda. How much? 74 lambda. Can you all add the constants? 21, 24 minus 3. How much? You mean with the 16. You're taking all these terms to the other side and adding with the 16. Minus 26 is the final answer. You mean taking this to the other side also. Equals how much? Minus 26. Which gives me lambda is minus 26 over 74 is how much? Minus 13 over 37. That's correct. Guys, we just took these green color numbers to the other side and subtracted them, just reversed the signs and added it with the 16, okay? This is okay, right? And then what? And then what? We substitute the lambda value. We found the lambda value. So now what? When you substitute the lambda value into the equation, go and substitute the lambda value into the main equation, the dt equation. The lambda value, when you substitute, you will get the exact coordinates of the point t. You will get the exact coordinates of the point t. Okay? So coordinates of t. So can you all substitute 3 plus 7 lambda, 6 plus 4 lambda minus 1 plus 3 lambda. Three plus 7 times minus 13 over 37. 6 plus 4 times lambda is minus 13 over 37. Minus 1 plus 3 times lambda is minus 13 over 37. Guys, are you okay with what I just did over here? So what is the answer for t? T equals 20 over 37. How much? 170 over 37 and minus 76 over 37. Is this clear? So these are the coordinates. So when you give the coordinate, let's give it the other way. 20 over 37, comma, 170 over 37, comma, minus 76 over 37. Yeah, so this is the answer. Okay, let me answer the question. What was it? Miss, one question. Why is the differentiation of sec to the power n minus 2x equals n minus 2 sec n minus 2 tan x and not n minus 2 sec? Okay, let me check on that. I'll go back to the question. I think there is a question about the integration, right? This one. You mean the differentiation of the cosec, right? Why is it? Wait, which question is this? Miss one, why is the differentiation of sec to the power? Am I looking at the correct question? Where did we work with sec? Which question did we have a sec? I think, Jane, you need to tell me the question. Which question did I work with a sec? Was it another paper? Where? Which question is it? Can you comment on which question it is? You mean cosec, right? There's no sec. There's no cosec. I'm trying to find the place. I don't think I've done a sec. It should be the. I think it should be question number 5, right? I assume you're talking about question number 5. Yeah. Yeah. So over here, your question is about this u dash cosec to the power n minus 2x. So the question is, why is the differentiation of that? Okay, so and the thing is, when you are differentiating, the priority goes to the power. First thing is you take the power in front. It's like this rule. It's like when you're differentiating some fx to a power of n, the differentiation rule is that you take the fx forward, the power forward. Let me show it like this. Okay, so if you are differentiating some function with some power, first thing is you take the power forward. Leave the inside as it is and subtract 1 from the power. After you're done with it, you go in and differentiate your fx. So fx differentiation is f dash x. This is how the differentiation works when there is a power. Okay, so when there is a power, first thing is take the power forward, subtract 1 from the power, leaving inside exactly as it is, and then you differentiate inside. This is exactly what I did in cosec. So n minus 2 comes forward, cosec n minus 2 you subtract 1, so it's going to be n minus 3. And then the cosec differentiation. The thing is, the differentiation of cosec is cosec cot. Okay, so you have to make sure you don't mix up the differentiation and integration rules. So I have like written all the rules here, differentiation and the integration rules. Let me show you. I think, yeah. So these are my differentiation rules. I think you can see. Okay, these are my differentiation rules. Can you see? So when you differentiate, now after you are done with the power, you bring the power forward, subtract 1 from the power. And after you are done with the power, you have to differentiate in. So cosec differentiation is minus cosec cot. Cosec differentiation is minus cosec cot. That's what I have written here, minus cosec x cot x. And you should even further differentiate the x, that's into 1. So I did not go to put into 1 because if there was, in an event, if this was a 2x, then it should be cosec 2x into minus cosec 2x cot 2x into 2, if it's a 2x. Okay, so these are like the rules that I have written, like general rules that you can easily use for differentiation. This is basically from P3, P4. Okay, these are the rules that I have written in a general way. Okay, I hope I answered your question. And then the cosec n minus 3 and the cosec power 1, these two cosec terms, they because the bases are the same, I can add the powers. I added the powers and I got cosec to the power n minus 2x cot x. Okay, I hope I answered your question. I'm not exactly sure, but you can let me know. Okay, but you need to, like, the thing is, you need to know all these differentiation. Now, for tomorrow, you need to know all these differentiation rules perfectly, and you must know the integration rules, basically the P3 integration rules and P4 integration by parts, P4 substitution. So those stuff you need to know it very well, right, for the exam tomorrow. Okay, so then I will end this live stream now. So if you all have any things you want to ask, you can contact me on Telegram and I will respond you via that. Okay? Okay, so all the best for your exams tomorrow. Okay, so you can contact me on Telegram. The link is there in the other F3 videos. You can contact me and ask me any doubts that you have. Okay? So we will end this from here.